Hi everyone, welcome to lecture 2 on mesh analysis problem. On this session, let us discuss mesh analysis with multiple sources. Problem statement: calculate current in 12 ohm resistor using mesh analysis for the following circuit. Now have a look at the circuit. I have 40 volt source, 10 volt source and 60 volt source. There are 3 voltage sources here. Let us analyze this circuit using mesh analysis to calculate current in 12 ohm resistor. As usual, I am going for two different methods. One is using loop equation, another one using matrix or inspection method. For loop equation method, step number 1 is to choose loop current as well as branch current direction. The loop current may be chosen any direction, either clockwise or anti-clockwise. There is no restriction or thumb rule for this. It is your wish. Say for example, I am going for always clockwise. I'll take this as first loop, I1 clockwise direction. This is second loop, I2, which is also clockwise. This is third loop, I3. So I have chosen loop current, all three belongs to clockwise direction. Now let us fix the branch current direction. Consider 12 ohm resistor. It takes only one loop current, that is I1 alone. So simply choose this branch current is same as your loop current. If you consider 4 ohm branch, it takes I1 current from right hand side to left hand side, I2 current from left hand side to right hand side. Before fixing branch current direction, you must assume one of these two current is greater. Again there will be a question, which current I have to assume greater? That is your wish once again. Say for example, I am assuming I2 is greater than that of I1. So I am choosing this direction. It may be right or wrong, it doesn't matter, but I am assuming in this fashion. Let me check later on what could be the result. So if I am choosing this direction, so I have to say I2 minus I1 is my branch current here. Then coming to this side, 5 ohm branch. 5 ohm branch, I1 is flowing from right hand side to left hand side and I3 is flowing from left hand side to right hand side. So once again, you are supposed to fix the current direction based on assumption that I3 is greater than I1. Remember, I am assuming that I3 current is greater than that of I1. I am choosing this direction. Now the branch current is going to be I3 minus I1. Because I am assuming I3 is greater, so I3 minus I1. Now coming to 7 ohm branch. There are two loop current here, I2 downwards, I3 upwards. So you have to assume one of the current is greater here. I am assuming it is greater, so I2 minus I3 is my branch current here. I have concluded loop current and branch current directions. Before moving to the rest of the problem, let us quickly have a look at sign convention for voltage source. If your loop current leaving positive of the voltage source, you have to assume positive sign for the voltage. If the loop current leaving negative of the voltage source, you have to consider negative sign for the voltage. Similarly, have a look at the sign convention for voltage drop. If your loop current and branch current directions are same, then you have to assume the voltage drop as minus I into R. Remember, small letter I represents your branch current according to this diagram. And if branch current is opposite to loop current, then you have to assume the voltage drop as plus I into R. So these two rules we have to follow while choosing voltage drop on any circuit. Let me go back to the problem. Step 2 is to apply KVL on loop and write down the equation. Let me take down loop number 1. You start from any one of this point of the loop and complete the loop at the same point. This is a loop I am considering as a loop number 1. I'll start from this point. Let me write down the loop equation. I'll consider a 12 ohm branch. So loop current, branch current both are same. So minus 12 into I1. Coming to 5 ohm branch, I am considering I1 loop current and I3 minus I1 branch current flowing opposite to that one. So plus I3 minus I1 into 5. Then considering 4 ohm branch, loop current I1 flowing opposite to the branch current I2 minus I1. So obviously plus I2 minus I1 is equal to 0. Then coming to loop 2, this is the loop I am going to consider as a loop 2 where 40 volt source, 4 ohm, 10 volt source, 7 ohm are present. So for loop 2, I'll start from this portion. I'll end with the same point. When I move forward, loop current leaving positive of the voltage source plus 40. Here on a 4 ohm branch, loop current and branch current both are same. So minus branch current I2 minus I1 multiplied with resistance. Next 10 volt source. Have a look at the loop current leaving negative of the voltage source. So minus 10. Then coming to 7 ohm branch, I2 is a loop current and I2 minus I3 is a branch current. Both are in the same direction. So minus I2 minus I3, that is branch current multiplied with 7 ohm is equal to 0. Now consider loop 3. Loop 3 has 5 ohm, 60 volt and 7 ohm, even 10 volt source. Let me start from this point and complete with the same point in order to write down KVL equation. Let me start from 7 ohm branch. I2 minus I3 is a branch current, I3 is the loop current, both are opposite to each other. So plus 7 times of I2 minus I3. Next 10 volt source, loop current I3 leaving positive of the voltage source, so plus 10. Then the next case is 5 ohm branch, I3 is a loop current, I3 minus I1 is a branch current, both are acting in the same direction, so minus 5 times of I3 minus I1. Then finally 60 volt source, loop current leaving negative of the voltage source, so minus 60 is equal to 0. Now this is the equation we found on loop number 1, and this is the equation we found on loop number 2, and this is on loop number 3. Equation 1 may be simplified like this, and from equation 2 you may get simplified version of equation, and finally this is from equation number 3. Then step number 3 is to solve the 3 equation what we found and find current I1. Why should I find current I1? Let me explain later. I think these are the equations we found earlier, and solving these 3 equations we get I1 with the value of minus 1.667 amps, I2 with the value of minus 1.5462 amps, and I3 with the value of minus 5.7631 amps. Finally, current in 12 ohm is I1. Let me go back to the problem. Have a look at this circuit diagram. Our intention is to calculate current flow in 12 ohm resistor. So current flow in 12 ohm resistor is I1. That is the reason why we are calculating current in I1. So current in 12 ohm is I1, which is minus 1.667 amps. This is the final result of this problem, but we have to discuss about minus sign here. Coming back to the circuit once again, for this direction of current flow, I found the answer. But the current magnitude is correct. Whatever the direction I have chosen here is wrong. Actually, current is flowing on this direction. This is right direction of current. And similarly on the rest of the two currents too. Have a look at I2 current, which is minus 1.5462, I3 current even minus 5.7631. That means the current direction I have chosen here is also wrong. I2 direction I have chosen clockwise, but actually it is anti-clockwise. I3 direction I have chosen clockwise, but it is actually anti-clockwise. So anyhow, I got correct answer at the end, but only change I have to make here is my assumption is wrong. But it doesn't matter, you'll get the answer correct. If you say current in 12 ohm resistor, in terms of magnitude you can say it is 1.667. But as per my direction, it is minus 1.667. So nevertheless, it is correct. Strictly speaking, it must be 1.667 from right hand side of the circuit to left hand side. Yeah. Coming to the second method, inspection method or matrix method. I am choosing the same problem, 12 ohm resistor current I need using mesh analysis. Once again, I am choosing the same circuit. Step number 1 here, find out number of loops and choose loop current direction. How many loops are there? Look at this problem. We have 3 loops. Find out loop current directions. So this is step number 1. And step number 2 is formulate network equation. How to formulate network equation? V is equal to Ri, where V represents voltage vector, R resistance matrix, I represents current vector. Voltage vector dimension is n cross 1, resistance matrix dimension is n cross n, current vector dimension is n cross 1. What about the value of n? N is equal to 3. That means voltage vector is 3 cross 1, resistance matrix 3 cross 3 and current vector 3 cross 1. Finally, you can expand as per the requirement of network equation. So 3 cross 1 means V1, V2, V3, R right from R11 to R33, I from I1 to I3. I'll take down the same circuit once again. Here, let me choose loop current direction. Once again, clockwise. No need to choose branch current direction here. Loop current direction alone enough. We are supposed to find out V voltage vector. Let me find out this one. So for finding voltage, we have to stick to the rule which I mentioned for the sign of the voltage source. Coming to loop number 1, I am not witnessing any voltage source here, so make it as 0. Then come to loop number 2. There are 2 voltage sources. One is 40 voltage source. On 40 voltage source, current leaving positive terminal, so plus 40, and current leaving negative of the 10 volt source, so minus 10. 40 minus 10. Then I'll consider third loop. Now I am witnessing 2 voltage source. One is 10 volt source, another one is 60 volt source. 60 volt source leaving negative of the voltage source, so minus 60. Coming to 10 volt leaving positive, so plus 10. So it is going to be minus 60 plus 10. The net value of voltage here is 0, 30 minus. Coming to resistance matrix, we have to stick to the rule once again for resistance matrix. This is sign convention for resistance. If both loop current are acting in the same direction, either upward or downward, you have to consider positive sign for the resistance. If one is acting downward, another one is acting upward, that means opposite each other, you have to consider negative sign. This rule to be followed while selecting sign of the resistance. Or let's find out diagonal element first. So on a first loop, 12 ohm, 5 ohm, 4 ohm. So there are three different values. And on a second loop, look at the second loop current here, 4 ohm, 7 ohm, only two values. Then third element, 5 ohm and 7 ohm, only two here, 5 plus 7. Coming to R1 to 2, R1 to 2 means between 1 and 2. Common for 1 and 2 is 4 ohm branch, this 4 ohm branch. How to take sign for this? Have a look at loop current 1 flowing from my right to left. Loop current 2 left to right, opposite each other. So take down -4 here. Then 1, 2, 3. Loop number 1 and loop number 3. We have 5 ohm. So this is also -5 because 1 and 3 loop currents are opposite each other. Then coming to 2 and 3. 2 and 3, we have a 7 ohm branch. This one, 7 ohm branch. So you have to consider 7. Do remember to take minus sign because I2 downward, I3 upward, opposite. Once you filled this R1 to 2, R1 to 3 and R2 to 3 value, you can easily fill the rest of the things because it is a symmetrical matrix. Then, so I concluded now formulate network equation on step number 3. So the same equation I am providing it here. Apply Cramer's rule to find out I1. Once again, why should I find out I1? I1 is a current flow in 12 ohm resistor. So I1 is del 1 by del. What is del? Determinant of R matrix is del. What is del 1? Del 1 is also R matrix, but what is del 1? Del 1 is also R matrix, but only change is voltage vector replacing first row of R matrix. That's it. Then find out current in 12 ohm resistor. Del 1 value is -1660 divided by del value 996. We are finding -1.6667 amps. This way you can cross check your answer. I hope you understand mesh analysis problem with multiple sources. For more updates, subscribe my channel.